Yes, yes,
And you can see my screen.
yes.
Oh, finally, so we have good network. Okay. Um, this is where we were struggling to come, but we are finally here. So here today we're going to be talking about rainfall. And in rainfall,
Okay, sorry. Sorry.
okay,
This Giovanni, like, it's just, I'll just go to, like, I'll check online
okay.
to open it. Okay. Uh,
So, so Giovanni, like it is says, it is a bridge between data and science.
okay.
Yeah, so I'll also share the link with you. And if you go through
Okay.
here, you see under select the type of plot, you can see different types of plot here, which you can select to visualize the data you're going to be working on. Then under observation, you have model, you have observation, you have reanalysis. Under discipline, you can see aerosol, you can see atmospheric chemistry, atmospheric dynamic, hydro. Then under measurement, you can see air, you can see CO2, you can see other different measurements. Then under platform and instruments, you can see something like Moody's, you can see different other instruments. Spatial resolution, you can see those in kilometers, you can see those in degree, 1 seconds, 0.01 seconds, degree, 1 degree, and rest of them. Temporal resolution, you can see 3 hours, you can see daily, you can see monthly, you can see yearly. Then wavelength, depending on the data you are looking for. Depth, you can also see it here. Then special feature like chromatography, so chromatology, so you can see different of them here. Now by this side is the date range. You can, the date you are searching, this is the range. You can choose the range, and this is where you can also get the boundary. So I will clear the boundary to be on default. Then here is the parameter. So all you just need to do is when you come here, I have my account already, which I've logged in. If you don't have an account, it's Earth Data, NASA. So you can click on and sign up. And when you sign up, if you are looking for data, for example, I'm looking for rainfall. So I'm going to type here precipitation. Now, when I come here and type precipitation, you can see I will click on at least one variable must be here if you want to search. Now, this is the date. I want to search the precipitation of 2012 or 2013. So let me make it 214. And the date range, I want it to be from January to, I want it to be January to December 2014 here, and then I am going to now select here and say December 31st. Now you see here that here, sorry, I didn't select 2014. Let me complete it. So I'm going to take it to January and I'm going to click OK. Now you see that I have January to December 2014. So I can now select the precipitation I want here. Then I can do search. Now on search, that is going to fetch you all the data as related to precipitation that fall within this date range. So you can see here, this is the data that fall within this date range. Now, another thing is, if you're interested in the entire world, there is no problem. But let me select by monthly. How do I choose narrow it by monthly? If I want to see the data by monthly, you can see here the temporal resolution monthly. But if I want to see it on its own, remember temporal resolution here, I can just come here and check monthly. And when I check monthly, this data is going to filter and only give me the one that is within monthly. You can see. So it is going to filter this. I see here it is still filtering. So you see now that the only
Okay,
one I have here are monthly. Yeah.
under measurement. Oh, okay, under temporal
Under
resolution.
temporal resolution.
Okay, sir.
Now, this is monthly. Now you see now that monthly, we have gotten this. Now for me, I might be interested in different. This one is from 1979 to 2024. Then you go again, you can see 1979 to 24. This is from 2000 to 2024. This is from 1948 to 2024, 2014, sorry. So depending on the data you are looking for, so you can now check which of them suit what you are looking for. Now, for example, if you go here, you see the temporal resolution, and this will help you know which of them have a higher temporal resolution or the one that have lower temporal resolution. So this you can choose. Now, this is from 1998 to 2019. This one, then this is monthly. So based on the spatial resolution you want, you can decide to use the one you want to use. So depending on the kind of research you are looking at. So in this case, I'm randomly going to choose TRM. TRM. So which probably I'm going to choose this. Now when I choose this, you can see I just selected this, which range from this to 2015. So and it is monthly at 0.5 degree. So in this case, here I have the rest of the data, but what is important is that I have selected this. Now the band, I am not going to do this. I'm going to come back to it. So I'm going to click on plot. Now it is now launching the workflow.
What of the location?
Yeah, that's why I say I'm not going to click on it for now, that I'm going to come back to it. Now, as you can see, this is the rainfall
For the whole, okay.
of the whole world. Now, it is not restricted anywhere, and it automatically plotted the this thing for you here. You can see this here, and it is interactive. You can zoom down to Nigeria. Here, you see a way you can visualize it. Now, there are options here which you can customize. If you want it the grid, if you want the title, the caption, the legend, you should change it. What do I mean? If I remove the title, it will go. Now, here, this is the range of the rainfall within this time period. Now, you can download it as NetCDF, which we are going to talk about, as JOTIF, the KMZ, and PNG. So this is what you
Oh,
can see in here, depending on how you want to download it. Now, I'm going to return back to where I was. So I'm going to click on back to data selection. I am going to uncheck this, and I'm going to look for the one that have 0.25 here. I'm going to check this, and I'm going to also say,
0.23.
yeah, 0.125. I think that's, yeah, I
Okay.
think that's the
Partial
default.
resolution.
Yeah, the spatial resolution, when the spatial resolution is 10 and you have another spatial resolution 100, it means that the one that
10.
have 10 is higher in terms of accuracy, or if it is satellite imagery, in the aspect of what you can see. So the spatial resolution,
Yeah.
when it is high, the number is low. The temporal resolution, when the number is high, the number is low. So in that order, that's the same thing here. So you see here now, this is for it, but this data covered only United States. You get that now. So this is from 2014 January to December. As you see here, this data only covered the United States. So you can see the different precipitation value here. Where it is high, you can see that there is more rainfall down Florida and then New Mexico. Then now I'm going to return back to the data. You see the where it covered. So on this case, you can use this to select the data of precipitation based on what you want and how you want it. So this is total resolution and rest of them. Now I am going now to return back where I am also randomly going to choose the data based on where they are located, and I'm going to come back here. Now on this case, I'm going to either click here, which is to select the shape from the list you see on the map. Then you have here, which is to draw the polygon on it. So I'm going to draw the polygon. So
Okay.
I want to change this into 2024. So I will change this to 2024, like we want to collect the data of, no, let's make it 2023 please, because we have not finished 2024. So let's make it 2023 here, and then make it 31st, and then also change this one here to also 2013, so that we just say we are looking for 10 years data. Now here I will click here as it shows if I'm interested in Nigeria or Africa. Then let me assume that I want to look for Nigeria. So I will zoom close to where Nigeria is. You see Nigeria here. I will zoom well. Now when I zoom, this is selected, tools here. So once it is selected, so it means that here any place I select become my place of interest. So I will zoom again better for Nigeria, and I can drag it here. So I am going to click on these tools here and draw a rectangle here across it here. Then this is covering Nigeria, and once done, this is done, you can see the coordinate have changed here. Now this is where you can select the shape. You see different shape you can select: world source from S3, world watershed, and rest of them. Once that is done, then you should be able to get
Which
all
one did
this
you
here
pick?
done. What?
Which one of them did you pick?
I pick these tools. I am saying that this is where you can select, but I didn't select. I just zoomed to Nigeria, use this to draw a polygon that covered Nigerian map. Is that okay? And
Okay.
automatically that gives me this coordinate. The same way you can enter this coordinate manually, separating them with comma, which is the coordinate of here and the coordinate of here. Once that is entered, you still get here. So once this coordinate is here, I can type now precipitation, and then I will click search. So while it is searching, so you see a good aspect of this is that it will give you a kind of plot view to what you want, you know, give a plot view to what you're looking for. So you will be able to see what is there. So you see this one, total precipitation, this is hourly. Total precipitation, this is monthly. So if we select this, so we need to know where did it cover, and if we say plot, then it says total precipitation have no data for the place you selected. You get it? This is
Okay,
why I
yes.
wanted to show you this. This is why I wanted to come here. That was
Okay,
why I
okay.
showed you the entire world first before showing you this particular one, because I wanted us to talk about this. So once I select that, you see what happened. Now for me to narrow my data to what I am looking for, remember where we say here, we say temporal resolution. I'm going to check monthly. so that I can get it. I don't, when we're talking about monthly, what it means is that the average rainfall has been processed and averaged by monthly. I don't know you get what I'm trying to say. So, it might rain high today, tomorrow it rain more, yesterday, next tomorrow it rain low, other one it rain medium. So this has been processed and it has been given to you in that pattern. So when you click monthly, you should be able to have the total precipitation based on monthly basis. Is that okay?
Yes, sir.
So if I select this, you can see it says this does not have data for this. Then if I uncheck
Yeah.
it, it will go off. Then if I select this
Okay.
one, it doesn't have data. If I check it
Okay.
again, it go off. So now if you see here, you see that this one have data to 2019. Now, but
Mm.
we want to look for the one that have 2024. So let's go for these ones that have 2024 here. Let's check it and see. So it didn't tell us that there is no data for this one. You see it?
Okay.
So we can now say, let us plot
Lot
for Nigeria. Now, do you know about what we call NetCDF?
NetCDF. No, sir.
Yes. Do you know about such data?
No.
Okay, while we are waiting for whatever we click to come, I want to tell you a bit as NetCDF. Do you get that? So let's talk a bit on NetCDF while we're waiting for it, because I'm going to expose you to um, I'm going to be telling you much about such kind of data, and we are going to be working on it. So NetCDF is
Okay.
Network Common Data Form. Now, it is a binary data which they use in storing, exchanging scientific data, especially as related to climate. So it is multi-dimension data. It's so there are different other net CDF which you can actually see, like climate data, weather forecasting data, oceanography data, satellite data, sensors data. Now, this comes in different formats. Like we have the next CDF4, we have HDF, that is it, not only TIFF that we have other these things like Python, like X-ray, Pandas, and MATLAB can visualize them. But the good thing about NetCDF is that it stores data in not just only X, Y, it is four dimension. So what it means is that it have more higher value compared to GRD or TIFF. So if you have a NetDCF file, it is going to be higher. For example, if you have a data that is in have a data that is in NetCDF of Nigeria, and you have another data in NetCDF of that another that is in GRD of Nigeria, the NetCDF will be higher. What it means is this.
Yeah.
Yeah, I mean grad or thief.
Okay. Thief.
Yes.
Thief.
Now, what I mean is this. You see this place we selected and we see 2024. You are going to download a data that can store one particular data, storing the monthly average of rainfall for you for over years as a single file.
Hmm.
So what you need to do is while you are working on it, you need to open it up. You get what I'm trying to say?
Okay.
Yeah, so it
I
stores it.
don't.
Yeah, it stores the data, and I will also want you to read about it. This format here, which is named NetCDF.
Okay.
Yeah,
Okay.
if you look
Okay.
here, you say download all data layer. Download layer will not reflect plot option. Download all. This one is PNG. You are just going to download this as picture.
Yeah.
This is
Picture.
KMSZ. This is GeoTIFF. But this NetCDF will download all the data of this layer in different dimension as one file.
Hmm.
You get what I'm trying to
Yeah.
say?
Yes, sir.
Okay. So you see here now, we have this. Then when you open here, you see this is the plot. Then when I open here, you see this one. This is a time average here. This is the second one. The first one I selected before. This is this one, the first one I did before. So automatically, because my account is here, it saved this here for me a bit.
Okay.
So I can clear this, I will remove it and I will delete it permanently. I will say yes. Then I can clear the second one here. As you see here, I will delete it permanently. Yes. So I'm just showing you this in case you have such kind of distance. Why is it showing like that? So for a quick one, when I am done, I can download this here, go to download here and say download it as PNG, meaning it will only show me the PNG as related, assuming that somebody tell you, please come to see the map of Nigeria based on climate. Approximately, what you can do is that you can come here and download this for the person and then to show the person this is the rainfall distribution of this place over this period of time. Now, I have
You said
downloaded it. I am opening it. What did you do? You didn't plot anything. But if you look here now, what is on the screen, you will see that it have done this for me here quickly plotted, and you can see map of Nigeria. The person can see the a rainfall distribution of Nigeria over this period of time. Remember, this is PNG. It is only showing you the first one, which is on January 2020. 13, sorry. This is what is showing you here. So the other ones are not there, but at least it gives you a clue of what is happening here. Now on this case, this is the rainfall I've downloaded. I've selected. So I'm going to go to download here and I'm going to click on NetCDF and I'll click on it. That is loading and that's going to start downloading. So it is downloading it in NetCDF. So it have downloaded the NetCDF file for us. So now we are going to launch ArcGIS. Now I am going
okay.
to teach you
Where
another.
it's in,
Is it?
where do you save it in?
I just downloaded it. It goes to my download folder.
Okay, okay, okay.
Yes. I'm going to teach you how to use Pinoplat.
Pine,
Yes,
pineapple.
Pinoplat. Yeah, so I will teach you, but not today. We're going to use climatic data to work on it, but not today. So today we're going to use ArcGIS. But why I wanted to show Pinoplat is that it is very good on using this type of data. So I'm going to show you how
Okay.
what
Just
we are
like
going to be
ArcGIS.
plotting.
I said, is it just like ArcGIS?
I'm opening it just to show you right now.
Okay.
It is not like ArcGIS. It specializes in making all this kind of plot in 4 dimension or 3 dimension or any of the climatic data. It is very very good. So they're like it makes for me it makes it work very very easy, fast for all of us. So the data which I'm going to show you while we're waiting for this thing to work, the ArcGIS to come up. But what I'm trying to tell you is that the Pinoplat really use for plotting a data as like the next CDF, the rainfall, so it reads it better and faster. So we are going to be using it, which I am going to share with you on how it works. I'm just trying to take you to a page where we can visualize what I'm talking about a bit while we're waiting for it. So this is a final plot. So it's is like this format. You see the way it is. So it actually uses like it comes in this way. With here, when you click on the data, you see here that I have a multi-dimension. As you can see here, I have rainfall monthly, I have T, which is time, I have longitude and latitude. So it stores this data, like I said, this .NetCDF, so .nc. So if you click on it, you should be able to see the details on it, as you can see here. Now I can, to create a plot, I just need to select the the data or the particular parameter I want to plot, and you can just see create. And once you create, it will automatically display this for you. So you can make a customization, make a control plot, which will, you see here, you can make it by monthly, and you can use it to create a GIF, the GIF data that you can visualize like an animation. You can overlay a data on it. So if you look at these steps which I take here, you should be able to see the way I followed in trying to plot this rainfall monthly. So as you see here, this is 1981 to 2017. With Pinoplat, you can plot these things like all the data will come as one, and if you want to gauge for each of the month, you can export all of them once for each of the month. You can see here, look at here, this is 1981, 1610, 16:9, 16:8, 16:7, meaning that all the data have been stored. If I want to plot all of them, like somebody asked you, I want you to produce a rainfall data for me every month for the next 20 years. So in ArcGIS, you're supposed to be doing one of them every month after the other. But in this place, I don't need to do that. So what I will possibly do is to select all of them as you see it here and put up the range date. After plotting one, automatically I can say export. So it's going to export all the map for me in single until it gets to the rest of them. So this is what I can use. So which, like I said, I will be showing you how to use that Pinoplat, because I want us also to look at climate data, climatic data, so which we are going to be working on. Yeah, you will understand it better then.